Hello, good afternoon. What I want to do today is to continue with definitive integrals or definitive integration. Now, one of the things I would like to thank those people who have commented. Now, it's important that you understand that you have to write out the information yourself and then see where it has come into play. Now, again, bear in mind that I'm only showing you my perspective as to how I have come to understand the process of integration as such. Okay, and you can understand it as well. You just have to find that niche that suits you and how that interpretation is applicable to yourself. Okay, but it can be done, right? And it can be done by practice, practice, practice. Okay, what I want to do now is to do the final part of integration. Now, please note, it's not final as in final. It's just final in respect of the information that I want to relay to yourselves at this point in time. Okay? Excuse me for a moment. I have got this correct. And my last video gave me a lighting problem. I have no idea why though, but I'm hoping that I will get better as time goes on. Okay? That's the idea. Now here, I'm looking at definitive definite integrals. I repeat that, definite integrals. Okay, integrals containing an arbitrary constant c. And now remember from the previous work we did, we were talking about a constant c. Okay, and you would have seen that in the equation which I have produced. Okay, in text. In the result, in their results are called indefinite integrals. Since their precise value cannot be determined, okay, without further information. Now, in regards to this type of definite integrals, you need additional information in order to come to a final solution. Okay? Definite integrals are those in which limits are applied. Now, here you need to bear in mind the format for setting out those limits and how those limits are expressed. If an expression is written as, here we are, open brackets, still open brackets, x, b, a. Now b will represent the upper value, a will represent the lower value. B is called the upper limit and a is called the lower limit. Now the operation of applying the limit is defined as x in square brackets, b represent the upper values, and a the lower values, equals b minus a. Now you need to apply this principle once you have achieved or been given the relevant data. Okay? Now the increase in the value of the integral x squared as x increases from 1 to 3. Now all we're saying here is that the value of x is going to increase from 1 to 3. And here we have our value b, which is represented by that, and a value a, which is represented by this. Okay? Now again, remember, you cannot just learn from the screen. You yourself have to write out the information. You yourself need to make sure that you write it out so you can understand it yourself. Make any amendments and notes for yourselves. Let me just pan out a little bit. I hope I don't pan out too far. Let me make sure I can get the light in. Okay. Okay. Yeah. Sorry about that. I'm just trying to make sure I can get the full screen in. Okay, so everything can be seen. Okay, thank you. Right, now that's just page one. So what I want to do now is look at page two. Now again, you cannot just guess this, you have to work it out and write out yourself. And please remember, all I'm doing here is giving you examples as to how I have applied a given process to reach a given solution. Now, looking back at the question which was posed, and let me make sure that I did pose a question. So let me just go back to page one a moment, okay? Let me make sure I'm on the right page also. Okay, bear with me for a second. And this is page two, okay? Sorry about that, excuse me. Right, yeah, no, just let me get into focus. Okay. Definite integrals. Applying the limits. And all I've done here now is to show you how these limits would come into play in regards to integration. So here we have our integration symbol, x squared dx. Now remember to look back at the other videos or live presentations to recall what dx is, okay? That's not going to be repeated. It's something for you to know and understand for yourselves. Only you can recall that information. No one else can. And when you write out information, it stays with you because your brain remembers what you have written. So apply that principle. We have x square brackets x to the cube over 3 plus c to the 3. Now 3 is our upper limit, 1 is our lower limit. 3 to the cube over 3 plus c minus 1 to the cube over 3 plus c. Now what I've then done here is to show you how this value here has suddenly become 3 times multiplied over 3. Now that's just the way I work. You might work differently. Some guys will just put this in brilliantly, and I've seen them do it quite proficiently. But for me, I felt that I needed to know where these values came from. So that's just the way I work. Okay, that's over 3. Now remember, plus c is a constant. There is no value at this stage for c. It has not been given. So you can ignore that, but it has to appear in the equation as well. Okay, minus 1 times 1, again 1 to the cube, okay, plus c over 3. Now, when you multiply these, you get 27. Now make sure you're happy with that value yourself, that is what you get, okay? Over 3 plus c, minus 1 over 3. Now remember, when you multiply 1 by 1, whatever, it will still come out as 1, okay? So that's a third plus c, the constant. Now we have no value for c, the constant at this stage, so we don't need to worry about it. But when you divide 27 by 3, it gives you 9 plus c. Minus, divide 1 by 3, it gives you 0.333. Basically, it's a third. But I went through the process of actually doing it as a decimal format plus c constant. Now, we need to subtract this from this. And when you've done that, it will come out to 8 2/3. And you'll find that process is correct. Now, I use a guy's book, again, as I've mentioned previously, John Bird, and again, a guy called Greer. But Greer is many, many moons ago. But I found their guidance and the examples that they've given to be quite useful, helping me to understand in the past and in the present times now. especially when it comes to engineering mathematics. Okay. Now let me just pan out a bit so you can get this in fully. Okay. I hope that is the case. Okay. Now here, what I've done now, definite integrals. What I've done here is that I've going to do an example. The first part was to provide you with information as to how we can apply that process. So again, write that information out for yourselves. Make it your own. Look at what has been done. Here, evaluate A, integration of 3x dx, B, integration of 4 to the minus x squared, with upper limits of 2 in this case, and 3, and lower limits of 1 in this case, and minus 2 in this case. Okay. Now, let's look at the solution for A. Integration symbol, upper limit is 2, lower limit is 1. 3x dx equals. Now, again, it's just how I work for myself, because I need to see where things come from and how they have been arrived at. So here, 3x squared, upper limit to 1. We know from previous, the square is given for more information, basically, prior to this. Okay. So again, read the information prior to coming to do the example. It tells you exactly how this is achieved. Okay. Now 3x squared over 2, upper limit is 2, lower limit is 1, equals 3 over 2 2 squared minus 3 over 2 1 squared. Now do a little bit of research for yourselves, because to try to define each element would be too complicated. But do a little bit of the research, look at how other people have done it for themselves, and apply that principle to your own. Okay? Now here, if you divide 3 by 2, you get 1.5. Times 4, minus 1.5. Now 3 divided by 2 gives 1.5 times 1. And you can see here 2 times 2 is 4. 3 divided by 2 gives 1.5. Minus, with your function here, 3 divided by 2 gives 1.5. 1 squared will still be 1. Okay. Now, if you multiply 1.5 by 4, so let me just get it on screen. Minus 1.5 times 1, you'll get 6 minus 1.5, leaves you 4.5. Or if you want to say 4.5, which is more appropriate. But because you're putting it into a calculator of the sort, it'll be 4.5. Okay. Now again, you need to write this out for yourselves. Look at the process I have applied. Okay. This here is equal, becomes this solution here. That then becomes down to here. Okay, you can see where these come from, basically here and here. Okay, it's just the application of the principle. Okay, now do some reading for yourselves, do additional research, look at how other guys has done it in other maths books, and see that you can acquire the same skills for yourselves. Okay. Now, continuing from page 3, and again, definite integrals, we're looking at part B. What I've done here is, again, you're familiar with this by now, 4 minus x squared in brackets dx equals 4x minus x to the cube over 3. Again, your upper limit is 3, lower limit is minus 2. Now, I've rewritten this out. Again, remember, it's how I work, purely how I work, because I need to see where things come from and how they have been arrived. So here, 4 times 3, etc., minus 3 to the cube over 3, minus 4, minus 2, minus 2 to the cube over 3. Okay? Now, I've multiplied this by 4, 3 by 4, giving me 12. 3 to the cube. Now, when you multiply out 3 to the cube, it will come out to a given number. I'm not going to tell you the number yet, because it's in the equations. Okay? And when you multiply 4 by minus 2, it gives you minus 8. Minus 8 over 3. Okay, because here you have minus 2 times 3. Now, I am looking at this now. When I did it earlier, it seemed correct. Yes, it is correct, but it's okay. Just a thought came into my head at this moment in time. But there must be a reason for that. So bear with me. Let's continue as well. Okay, that gives us 12 here. We know that for sure. Okay, here gives us minus 8 minus 8 over 3. Now that gives us 27 over 3 minus 8 minus 8 over 3, which gives us 12 minus 9. Because 27 divided by 3 gives us 9. Minus. Now when you divide minus 8 by 3, it gives you minus 2.667. Okay, and when we take 12 minus 3, apologies, 12 minus 9 gives us 3. Now we're subtracting this function from this function, but remember that minus and a minus makes a plus. So when you take 3 minus 5.33, that actually comes out to 8 and a third, or 8.33. Okay. Now it's okay. It's okay. I'm looking through this, and it's something a little bit is in my mind. Something I have to confirm that for myself. But I'm going to leave it there for a moment, and when I check it out again, I will, if there's any concerns that I have, I will let you know. Okay, but that's the process we can apply. And interestingly enough, I checked this in my book and in the book actually as well. Oh, sorry about this. Let me just pan this out so you can get it fully. Okay, let's hope it pans out without too much of it being lost. Okay, I think that's about it there. Okay, it normally gives me a glare when I play it back, but I have no idea why at this point. Ah, sorry. Okay, right. That will be it for now. Thank you. Let me just bring this back into line. Okay, so we can then see it out. I just want to make sure that every opportunity is given to view this in full. So, okay, I was just trying to look at something there as to what I did, but I will check it off screen. Okay, thank you for your time. I hope that you will find this useful. Have a good day. Bye bye.